What is going on YouTube? My name is Brent and welcome to part 8 of my tutorial series on how to create the game Super Mario Brothers. So in this tutorial we're going to create a Mario class that includes a Mario body and fixture. We're going to add gravity to our world and we're going to set our camera to follow our Mario body. So we're making a lot of progress in this video. If you want to know more, stick with me. So to get everything started, let's create a new package called Sprites. And inside this Sprites package, we're going to create a new Java class called Mario. And Mario is going to extend the Sprite class from Bad Logic Gaming. So let's go ahead and create a couple variables here. Public world, world. This is the world that Mario is going to live in. So we'll take that in. And then public body. We'll call this B2 body for Box2D. And then let's create our constructor, public Mario, and it's going to take in the world that Mario is going to be generated in. And then we'll say this world equals world, and then we'll call a function called define Mario. So let's make that function here. Public void define Mario, and we're going to create a new body definition called bdef equals new body def from Bad Logic, and then bdef dot position, we're going to start position Mario at 32 32. This will be temporary, and bdef dot type equals body def dot body type dot, and this is going to be a dynamic body. Now that we have the Box2D body defined, we can go ahead and create it in our world. So we'll say b2 body equals world dot create body with our body definition. And we can move on to our fixture def. We'll call that f define equals new fixture def from Bad Logic. F def will also need we'll need to create a shape. So we're going to create a new circle shape and call this shape equals new circle shape. And then we need to set the radius of the circle. So circle shape dot set radius, and we'll set that to just 5 for now. See what that looks like. We'll say fdef dot shape equals our shape, and we'll tell our body b2 body dot create fixture using our f definition. So in order for Box2D to execute our physics simulation, we need to tell it how many times to calculate per second. So inside of our update method here, we're going to say world.step, and then it's going to take in a timestamp of velocity iterations and position iterations. The velocity and the position iterations are beyond the scope of this tutorial, but basically it affects how two bodies react during a collision. The higher these numbers are, the more the longer it takes to do the calculations, but the more precise. But we're gonna leave that there for now. What we're gonna focus on is the timestamp, which is 1 over 60f, so 60 times a second. We're gonna set velocity to 2 and position, or 6 and position to 2, and you can read more about that. I'll put it in the description below. So hitting the run button now, we'll open our game up. We should see our little Mario fixture fall on the screen. Here we go. So you see it started up there and it dropped relatively slowly, and let me go ahead and tell you why. So a problem that we're seeing is actually due to Box2D scale. Box2D uses meters, kilograms, and seconds for its unit measurements. So right now, our Mario being a radius of 5 is actually 10 meters in size, so about 30 feet. And this is the root of our problem and is the reason that he appears to be falling so slow. So let's go ahead and fix that. So let's go ahead and go to our main Mario Bros class and create a public static final int called ppm, or pixels per meter. And so we're going to set that to 100. So now going back to our play screen, we need to scale everything by those pixels per meter. So even our viewport, we're going to scale by pixels per meter. Our orthogonal tile map renderer needs to be scaled as well. The constructor takes in a second parameter here, and we'll scale, and that's the scaling. So it'll be 1 over pixels per meter. And then we have to scale this. I'm going to do this once here. So we're going to get this divided by 2, and then scale by Mario Brothers pixels per meter. And we'll also have to do the same thing here. And again, divided by that, divided by that. Now you'll do this for the other 3 things. I'm going to save you the time. So one error is that we don't actually want to scale our gravity. That's for sure. And then you can see that I've just gone through and done the exact same thing with the scaling for the pipes, the bricks, and the coins. Also, we want the ppm to be float, not an integer, for divisional reasons. So go back to sprites and your Mario sprite. Go ahead and change its position as well to 32 divided by the ppm and 32. And then also change the set radius by the ppm. So I know all that scaling was a little bit messy and a little bit of a bummer, but now we can actually move Mario around our game world, and all of that work is going to pay off. So let's get to the good stuff. Let's go to handle input. This is where we're going to do all of our input handling. We'll delete all that. We'll say if gdx.input.isKey just pressed, and we're going to check if the up arrow is just pressed. So to get that, it's input.keys.up. Now there's 2 ways to move an object in Box2D. The physics way. You can use a force, which is a gradual increase in speed or decrease, and you can use impulse, which is an immediate change. So in the original Mario Brothers, it looks like a jump was an immediate change. So we're going to use an impulse for the jump. So we're going to say player.b2body.apply linear impulse. The first is the x and the y of the impulse. So do we want to impulse in the x direction or the y direction? For a jump, of course, it's the y. So new vector 2 and 0 on the x-axis and 4. I found that works best. You can adjust these as you like. And then the next is player.b2body.get world center, and this is where in the body we want to apply this impulse or force. If we were using force, if you apply it off center, then there's going to be a torque to the body, and we don't want that. It'll change the angular, and it may spin off the screen or whatever. So we're applying it directly to the center of our body. And finally, the third parameter is will this impulse wake the object up? And I discussed that earlier about it not calculating in the physics simulation if it's asleep. So we want it to wake the body up. Next, let's handle the conditions where our left or our right button is actually being held. So to do that, we'll say if gdx.input.isKey press, not just press, because we wanted to know if they're holding it down. And we're going to say the first one will be the input.keys.right. And we also want to check to make sure that Mario isn't moving faster than a specific speed. So we're also going to check and player.b2body.get linear velocity is less than or equal to 2. I found these numbers work. You can adjust with them any way you want, but since we only have a short amount of time, just trust me with these numbers specifically. And of course, you can create these as global variables up at the top and name them specifics, but we don't have time to do all that. We've got a lot to go through. So if these conditions work, then what we want to do is player.b2body dot apply linear impulse new vector vector 2, and it's 0.1 f, the speed in the x-axis, 0 in the y-axis, and then player.b2body.getWorldCenter, and true. And the get linear velocity also needs to be, we're just checking the velocity in the x-axis. So let's go ahead and copy this. So copy that. And then we'll just paste the next one here. They're holding the left button, and this is greater than or equal to -2, then we'll apply a -1f velocity in the x-axis. And make sure none of these were in the brackets like I just had to fix here. So these are all being checked individually. So the last thing we want to do is in our update method, every time our Mario moves, we want to track him with our game cam. So what we'll say is game cam dot position dot, we're only tracking him in the x-axis. We don't want the cam to jump up and down with him. Equals player dot b2body dot get position dot x. So here is the moment you've all been waiting for. I've gone ahead and hit the play button here. So let's go ahead and check out our game now. So you can see first off that Mario, the camera now follows our little Mario fixture here. He's colliding with the ground correctly. He can jump a decent height. He collides with the bricks. He collides with the coins. He collides with the pipes. Everything is functional. So he can get up to the higher than the tallest pipe here. Let's go up here. Check out the whole world. We have made awesome progress, I think. So he can still jump multiple times. You can tell, like, I can almost like a little Flappy Bird action here, but we'll fix that in another tutorial. I know some of this code's a little bit sloppy, like, you know, naming our variables instead of using constants and stuff like that. I can do that, but, you know, to be honest, it's just taking up more time in the tutorial. I want to make sure I show you pretty much every step that I'm taking. So to do that, we kind of have to take some shortcuts. Not the greatest programming practices, but it is working. If you guys take the time to do those good programming practices, then your game will be much more socially or programmatically acceptable. So that's pretty much it for this video. We got a whole lot done. We're making a lot of good progress towards our end game here, no pun intended. If you like this video, go ahead and hit the like and subscribe button. I'd greatly appreciate it. But more importantly, please share it. I'm trying to grow my fan base here. If you're feeling generous, check out my Patreon page. I give you 2 big thumbs up for that. I appreciate everybody watching, and I'll catch you guys next time.